All right, so here we have example problem 2b. It's the second half of the of example problem 2. And what I wanted to point out to you, and this question asks if they're fired at the same instant, if cannonball A and cannonball B are fired at the same instant, which one reaches its maximum height first? All right, well, if you need to go back and look at it, go ahead, but I want to start how we got here. I want to start with this relationship right here, okay? We established that mathematically, right, based on all of our other derivations, that in order for them to achieve the same max height, they had to have had the same y components to their initial velocities. So we proceeded from there to find out what that initial velocity needed to be for cannonball B. But let's go here, because what we want to know is how long it takes to get to its maximum height, okay? And how does that relate to its initial y velocity, or the y component of its initial velocity? All right, so let's go to a new page here. And what I want you to think about is our special information. The special information we have that is that in general, when we are at maximum height, we know that Vy is equal to 0, okay? Vy is equal to 0 at delta y max, all right? Well, delta y max is the same for both of them. You recall that. And we know that they have the same initial y velocity. So now, if we think about this, we can say that we know that their initial y velocities are the same. I'm not going to mess around with the different colors this time. All right? The initial y, or the y component of the initial velocity, is the same for A and for B. We know that their final velocities up at the top are also the same. They're both equal to 0. We know that they are both in the same gravitational field. Okay? That sort of goes without saying, but let's just make sure we understand that they're in the same gravitational field and that they both will experience the same acceleration. If we want to, let's make that negative just to be clear there, right? Their acceleration, the acceleration for each, negative g for A is of course equal to negative g for B, okay? So now what we're trying to find is, how will their times compare? All right, what will be the comparison of time A for time B? Well, I think it's starting to shape up for you where you can see that this is sort of a trick question. Let's look at the things we have. We have initial velocity, we have final velocity, we have acceleration, and we have time. This is a simple VOTAT problem, right? V equals V naught plus AT. For us, since we're dealing with vertical motion and gravitational acceleration, we can say that Vy is equal to V naught y minus gt. Okay? So, in general, for any object that has an initial velocity v naught y, its Vy will be equal to this, we can determine it based on this relationship right here. Okay? So now, what are we looking for? We're looking for time. So in general, still notice we haven't put in any specific information for A or B. We're just saying in general, we know that the time it takes for an object to reach its maximum height can be given by a little algebra here, Vy minus V naught y over negative g. They might look at that and say, oh, wait a minute, we're going to have negative time. But that's not true, because since Vy is equal to 0, we would have 0 minus V naught y over g, or if you prefer, just negative V naught over g. Okay, V naught y over g. All right, let's take a look at what that means for us. If we know, now this is still a general expression, right? Now, we know that t is equal to negative V naught y over negative g. We'll just get rid of the negative sign here, cancel those out. What did we say about their initial, the y component of their initial velocities? If they're going to achieve the same height, then their V naught y's were the same. We said that up here specifically. their v naught y's are the same. If their v naught y's are the same and they're in the same gravitational field, then that means that T for A is going to be equal to T for B. Okay? Hopefully you sort of achieved that conclusion before I actually ran it all the way through, but it is a bit of a trick question. The idea is not only does their maximum height depend solely on the y component of their initial velocity, but so does the amount of time that it takes to get up there. Okay? If you take a look at this, it makes sense if you think about these numbers. Let's take these numbers right here to start with. I'll get rid of these green circles. All right, let's take a look at both of these. What we're saying is this right here, this v naught y, every second it's going to slow down by 9.8 meters per second. Right? 9.8 meters per second squared is 9.8 meters per second each second. So every second it's going to slow down by 9.8 meters per second. So just imagine for a minute, just pick a number, 98. So if it's at 98, it's going to slow down by 9.8 the first second, slow down by 9.8 more the second time. As you can see, it's going to take 10 intervals of 1 second or 10 seconds to slow down from 98 meters per second to 0. Okay? So all of this really makes sense if you think it out. Of course, the answer to the question that was being asked was the time A is equal to time B.